In 56, it says, at the school carnival, Mike will play a game in which he will toss a penny, a nickel, and a dime at the same time. He will be awarded 3 points for each coin that lands with heads face up. Let the random variable x represent the total number of points awarded on any toss of the coins. What is the expected value of x? Now, expected value is a very specific phrase. What that means is that we take each different outcome, and usually those outcomes have some kind of number associated with them. In this case, it's points, and we multiply it by the probability of each event. So what we first have to do is we have to figure out what is the probability of getting all heads, or maybe one head or two heads. So the way I'm going to draw this out is I'm going to use what's called a tree diagram. So first we're going to say the penny. Now, the penny can do one of two things. It can land either heads or tails. Now, we're going to assume that these are fair coins because they don't tell us otherwise, which means it's going to land heads half the time. It's going to land tails half the time. So here are half our outcomes, and here is half of our outcomes. So next, we're going to look at the nickel. Nickel, we're going to flip. And so we've got heads and tails for the nickels. Now it could land heads or tails regardless of how the penny landed. And so now, with the nickel, what happened? Well, now the nickel has an even split. It can either go heads or tails. So this is also half and half, but we started with 1/2 already. So this is 1/4. 1/4, 1/4, 1/4. Because we have to split this half equally, and we have to split this half equally. So now we have 4 different outcomes. And then finally, we've got the dime. And so the dime is going to do the same thing, heads, tails. So we've got heads and tails, heads and tails, heads and tails, heads and tails. Now each coin flip is going to split this evenly. So that means 1/4 is going to be 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8. All right. Now I'm going to create myself a little table down here because this shows all the outcomes. Now what do we care about? We care about heads. Now, we could be really unlucky and have 0 heads, a little more luck and get 1 head, more and get 2 heads, or be really lucky and get 3 heads. Okay, so how many instances in this entire tree do we have all 3 heads show up? Right here. That's our probability of getting 3 heads. It's 1/8. What about 2 heads? Well, heads, heads, so let me just put that as a 3. So we got heads, heads, tails. That's 2. Heads, tails, heads. That's 2 heads. Heads, tails, tails. That's 1. Now we go the other way. Tails, heads, heads. That's 2. Tails, heads, tails. That's 1. Tails, tails, heads. That's 1. And then tails, tails, tails. That's none. All right, so how many instances had 2 heads? 1, 2, 3. And each one has a probability of 1/8. So that means 3/8 because there's 3 of them, 3 different outcomes. For 1 head, we do the same thing. 1, 2, 3. So that's a probability of 3/8. And then for 0 heads, there's only 1 outcome right here. So our probability is 1/8. So what do we do? Well, now we take these outcomes, these probabilities, and we multiply by the number of points. So if you get 0 heads, you're going to get 0 points for that. If you have 1 head, you're going to get 3 points for that. So 3/8 times 3, now you could think of this as 3/1, so that's 9/8. 2 heads, you're going to get 3 points for each coin that lands heads face up. So you're going to get 6 points. So when we multiply 3/8 times 6/1, that's 18/8. Now, I could reduce 18 over 8, but I'm not, and you're going to see why in a second. And then finally, 1/8 times 9, or 9 over 1, so that's 9/8. Okay, so what do? I add all these up. So 9/8 plus 18/8 plus 9/8 plus 0. Well, when you add fractions, you always have to have a common denominator. That's why I didn't reduce this one. I kept them all the same denominator, so it makes it a little easier. 9 and 9 make 18, and then 18 plus 18, that gives us 36. 36 over 8. All right. So now at this point, I look and I see that 36 over 8 isn't one of my answers. Well, that's because I can reduce this. So if I take a 2 out of the top, I get an 18. Take a 2 out of the bottom, I'm left with 4. And 18 over 4 isn't up there, so I got to keep going. So I take a 2 out of the top again, and I take a 2 out of the bottom again. 9 halves. And so that right there is our answer.